Okay, this is 5.3 screencast notes. Let's start with our notes for the big or key ideas. So the first step, step 1, we want to multiply if necessary. One or, let's get that word better, or both equations by a constant. So at least one pair of like terms, whether it's the x's or the y's, of like terms, or it could be another variable, has the same, that's if you're subtracting them, or opposite if you're adding them, which I lean towards is a little, I think, easier for students, the coefficients. Okay, that's step 1. Step 2, we add, which I prefer, or subtract if they're the same. And we'll get into that later. We already went through that with our activities, so you know exactly what I'm talking about, whether you want to add or subtract the equations. So we're going to lean towards adding, but you can subtract if you find that easier. So we want to add or subtract the equations to eliminate one of the variables. One of the variables. Okay, step 3 is we want to solve the resulting equation to eliminate I'm sorry, that's not true. We want to solve the resulting equation for the remaining variable. And step 4, and we're going to go through these steps. So step 4 would be to substitute, like we did in our substitution method. When we get a value for one of the terms, then we're just going to substitute that value with a value that we got from step 3 into one of the original equations and solve for the other variable. So we have a solution there. And then the last thing we want to do always, always, always is check our solution. And that's through or by substitution. Sorry. In both original equations. Okay, so there are our key ideas, our 4 or 5 steps, and now let's go through the examples. Okay, so you've written the notes, and now for the number 1, it says to solve by elimination. And in step 1, it says that multiply if necessary, if we don't have opposite like terms. If we look at the x's, well, they're not opposite, they're the same term. But if we look at the y's, I have a +3 and a -3, they are opposite. So I do not have to multiply because I already have that. So I'm just going to go ahead, they're going to cancel, so I just cancel them out, and I have 2x equals 14. So there we go. Step 3 is to solve it. So I'm going to divide 2 using the division property of equality on both sides, and x equals 7. So my x solution value is 7. Now let's try to find y. And how do we do that? In step 4 it says we'll substitute this value into one of the original equations. So let's take the top one. X plus 3y equals -2. And now I'm going to substitute that 7 where the x was. So there's 7 plus 3y equals -2. And now I can solve it by subtracting 7 on both sides. Cancels out. 3y equals -9. Divide by 3 on each side, and y equals -3. So let's put a -3 here. Very nice. That was 7 comma -3. So step 5 is one of the most important. It says to substitute into both equations to see if it is the correct solution. So here's my x and my y value. I'm going to substitute 7. And then every time I have a coefficient in front, now that y of the term, there's a y, open parentheses, you're going to insert the number. It just happens that that's a -3, and that's always good to put parentheses around anyway. So here we have a 7, 3 times a -3, -9, or -9 equals a -2. 7 minus 9, -2 equals -2. Yep, that's the correct solution, but let's do the other one. The next original equation is x minus 3y equals 16. Substituting the values, 7 minus 3, put a -3, or value of y equals 16. 7, -3 minus 3 is a +9. A negative and a negative, a positive. And then when I add 7 plus 9, I get 16 equals 16. So our solution is correct. It's 7 comma -3. Okay, so here we have example 2. We have -6x plus 5y equals 25, and -x minus 4y equals 14. So again, the first step is take a look. Do we have opposite like terms? Well, I have a -6, -2. They're not opposite like terms. For the y's coefficients, I have a 5 and a -4. Not opposite like terms. So what would be the easiest number to multiply to get the opposite like term? And I see here, if I look at and I'm just going to get another pen. If I look at -6 and a -2, if I multiply the -2 by another -3, another negative, -3 times -2 would give me a +6. So that would be opposite like terms. So that's exactly what I'm going to do, but you just don't do that one. It's going to be multiplied throughout the equation. So we're going to rewrite this one. Let's write well, usually I just write it over here. I make sure I have room. So let's do that in black. So this one I'm just writing over -6x plus 5y equals 25. I didn't do anything. But this, a -3 times a -2x is 6x. Now I have opposites, but you have to do it throughout. And remember, that's a -3. So -3 times a -4 is a positive 12y. And a negative 3 times a 14. Oh, sorry guys, so a negative 3 times the 14 is, let me see, 42. And now we have our opposite like term. And once we have our opposite like terms, we can add the equations. These cancel, and I have 5 plus 12 is 17y equals, oh, I'm sorry, and that would be a negative 42. Negative 3 times 14 would be a negative 42. Okay, so a 25 minus 14 is 17. Now we use the division property of equality. On both sides of the equation, we can divide by the same number, and we get, and that would be a negative also. Oh boy, I'm forgetting my negatives. That would be a negative 1. So y equals negative 1. Okay, so let's just go through that again. This negative 3 was multiplied by negative 2, giving it a positive 6. Negative 3 times negative 4, giving a positive 12. Negative 3 times 14, giving a negative 42. And when I add those, I get a negative 17. So negative 17 divided by 17 is a negative 1. And now we go into step 4, and I'm going to substitute that negative 1 into one of the original equations. So I'm going to take the top one, negative 6x plus 5, and I'm going to insert for y a negative 1, and it equals 25. So negative 6, 5 minus 1 is a negative 5, equals 25. Then using the addition property of equality, I'm going to add 5 to both sides. Canceling that, I get negative 6x equals 30. Division property of equality, divide by 6, negative 6 on both sides, and I get x equals a negative 5. So it looks like we have a solution of negative 5 comma negative 1. So what do we have to do? We have to check it. So negative 5 comma negative 1. And we've got to go back to our original equation and substitute. So the first equation was negative 6x plus 5y equals 25. And I'm going to substitute the values now for x and for y. And so this is negative 6, remember open parenthesis, times negative 5 plus 5, open parenthesis. Let's insert what the value of y is, negative 1 equals 25. Negative 6 times negative 5 is 30. 5 times a negative 1 is a negative or a minus 5 equals 25. And 30 minus 5 is 25 equals 25. And perfect. That worked out. Let's do the second equation. We have to make sure it is a solution for both. So I want to make sure we're correct. And you should check also every single time. And let me just make that 4 a little better. 4y. Okay, so let's start substitution. Substituting the solution, negative 5, where there's an x, and minus 4, and where there's a y, negative 1, and that should equal 14. So negative 5 times negative 2 times negative 5 is 10. Negative 4 times a negative 1 is a plus 4 equals 14. 14 equals 14. Perfect. That is our solution. We have completed it, and then we know it's correct. So that's the solution for both equations. Okay. Okay, before we do go on to our last example, let's go back and do on your own problems. On page 218, number 1 and 2 from example 1, and page 220, numbers 4 and 5 from example 5. We'll take a break, and when you're ready, we'll get back to the last example, a real-life application. Okay. Okay, so you buy 8 hostas and 15 daylilies for $193. Your friend buys 3 hostas and 12 daylilies for $117. Write and solve a system of linear equations to find the cost of each daylily. So the first thing I want to do is I want to see what I need, what they're asking, what I have. So I'm buying, or first you're buying, you buy 8 hostas and 15, that's an 8, whoop, and 15 daylilies. And that cost you $193. And your friend bought 3 hostas and 12 daylilies, and that cost him or her $117. So that's the information I'm given, but it's asking me to write and solve the system to find the cost of each daylily. So we want to know the cost of a daylily. We don't know any cost. We only know that 8 hostas and 15 daylilies cost $193, and we know that 3 hostas and 12 daylilies cost $117. So how do we know just the cost of the daylilies? We don't know cost, so that's a high sign to start identifying variables. So let's define the X for the cost of hostas, and Y the cost of daylilies, which they were asking for. Okay, that we know. With all this information, now I can write a 2 equations. Pretty easy, I think. I have 8 hostas. Well, 8 times the cost would give me that total. 15 daylilies here. Let me just get a highlighter maybe. Let's see. The 8 hostas, when I multiply it by the cost, will give me the total cost of 8 hostas. Same way when I have the daylilies, if I have 15 daylilies and I have the times the cost, it's going to be the total cost of the daylilies, and that's going to equal $193. So I think it's pretty clear that we're going to do the number of plants times its cost, which is X, because we don't know that, plus 15 daylilies times its cost. We don't know that either, but we know it adds up to $193 for your purchase. But your friends now has 8 hostas. We don't know how much per hosta, but if we multiply that by 3, we're going to get the total cost. 12 daylilies, 12Y, and that's going to equal a total cost of $717. And so now we have our 2 equations, and we could start to solve the system of equations. Okay, so we have our 2 system of equations, the 2 equations to represent the cost of a daylily, which we're looking for. But we have to solve for Y to find the cost of the daylily. So when we take a look at both equations, and the top and the bottom, we see that it's not opposites. We don't have the same like terms. Even if I multiplied, let's say this 3 times 2, I get 6. They're still not opposite. And the same goes with the 15 and the 12. I can never multiply just one of the equations. So here it looks like we're going to have to multiply by 2. And I think the easiest way is, what would be the least, what did I do? The least number, or what multiple do I have for 8 and then the same multiple that I have for 3, and the lowest common multiple you want. So I'm going to do the 8 first, and I find that it's easier to do the multiples. 8 times 1, 16. 8 times 1, 8. 8 times 2, 16. And 3, 24, 32, and 40. That's the multiples of 8. Let's do the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 20, 24. Up, I see 24. Looks like it's here. 8 times 3 is 24, and 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 24. So we know that these can be, if I multiply this by an 8 or a 3, I think I'll be good. We'll both have 24x on top and bottom. So the 8, I'm going to multiply by 3. So this whole thing, I'm going to multiply by 3. On the bottom, I want opposite. I want opposite integers. So here, I'm going to multiply by a negative 8. So when I do that, I have opposite integers. Okay, let's first do the top one. Usually, let me erase this because I like to do them side by side. So we already know what our multiple is. And now we can just go ahead and rewrite both after we multiply. So 3 times 8 is, oh, I have something in the way here. 24x. 3 times 15 is 45y. And 3 times 193 is 579. The second one, I'm going to multiply this by the negative 8 so I can get a negative-like term, negative 24x. Negative 8 times 3x, negative 24x. And then negative 8 times the 12 gives me a negative 96y. And then a negative 8 times a positive 117 gives me a negative 936. Very nice. So here, I know we have opposite integers now with our x values, or x variable. So I'm just going to go ahead and add them. These cancel out. Oh, I always do that. I'm dropping down. You can't see, but the screen gets, I can't write on the screen. Anyway, so 45y minus 96y is negative 51y. Let me write that again. Negative 51y. And that's going to equal 579 minus 936 would be a negative 357. And then when I divide by a negative 51 on both sides, y equals 7. So already I know for y, we already decided that y was going to be the cost of the daylilies. So each daylily cost $7. And I have my answer. Now we could substitute and find the number of hostas, and then we could check those answers, which we could very well do given time. But right now we have our answer. Each daylily is $7 each, so we are through. Now if you could, you can just do on your own on page, let me just see what page we're on. Page 220, and that's going to be number 7. Okay, and we'll check that when we get back to class. Have a good night.